Carbon is an extremely versatile element, so much so that there's an entire field of chemistry that's devoted to carbon. Carbon most often forms covalent compounds, so it makes sense for us at this point to just dig a little bit into some organic chemistry to help us have a few more models and chemicals to play with as we move along. So, organic chemistry, as I said, is the study of carbon and its compounds. We're going to spend a number of chapters looking at organic chemistry a little bit later on, but for now, let's just look at some very simple organic molecules that we can use as examples when we're looking at covalent bonding. The first group, or the first type of molecules we're going to look at are hydrocarbons. These are organic compounds that contain only carbon and hydrogen. And the hydrocarbons are sort of defined or named according to the bonding in them. So we have alkane hydrogens, A-N-E, alkane hydrocarbons. Those are ones that contain all single carbon-carbon bonds. They typically have the formula C sub n, H sub 2n plus 2. If we have a double bond, that's an alkene. Alkenes are hydrocarbons with a CC double bond. Typically have the formula C sub n, H sub 2n. And if we move up to a triple bond, now we're into alkynes. Alkynes have a triple bond, and they usually have the formula C sub n, H sub 2n minus 2. We construct the names of organic compounds using both those suffixes to tell us what kind of bonding there is, and a root that tells us how many carbon atoms there are. So if I only have one carbon, my root there is meth. If I have 2 carbons, the root is eth. 3 carbons is prop. 4 carbons is bute. 5 carbons is pent, and they're pretty standard roots after that. So pent, hex, hept, oct, non, dec. So if we want to name a hydrocarbon, we just need to choose the root that tells us how many carbons we're dealing with, and the suffix that describes the bonding. So let's look at a few examples of that. So if we've got a hydrocarbon with 4 carbons and only single bonds, 4 carbons is bute. All single bonds is an alkane, so it's ane. So this hydrocarbon is butane. Butane is a pretty common hydrocarbon. It's found in portable little clippy lighters. We have a hydrocarbon that has 7 carbons and a double bond. 7 carbons, the root there is hept. Double bond is an alkene, so ene, so this is heptene. Heptene, 7 carbons, a double bond. If we've got a hydrocarbon with 6 carbons and now a triple bond, 6 carbons, the root there is hex. Triple bonds are alkynes, so ine, this is hexine. So by pairing together that root and the suffix, we can name an awful lot of different compounds. Now obviously, carbon can bond with other things as well. That's what gives it its richness. We call those other things functional groups. So carbon can bond with a few different elements. The only ones we're going to really worry about for right now are a couple of the oxygen groups. So if we replace an H in a hydrocarbon with an OH, a hydroxyl group, we have what's called an alcohol. Naming alcohols, you name them the same way you would name the root hydrocarbon, but instead of that final E in the name, replace it with OL. And we'll look at some examples. The other oxygen group that's important for us is the carboxyl group, or the carboxylic acid group. If we replace one of the CH3 groups at the end of one of those chains with a COOH, that's a carboxylic acid, or carboxyl group. And for naming that, we just replace the final E in the name with an oic acid. So again, let's look at a couple of examples. Hydrocarbon has 5 carbons, only single bond, and an OH group. So it's not exactly a hydrocarbon anymore. Now it's an alcohol. So 5 carbons, that's pent. Single bonds, ane, it's got an OH, so it's an alcohol, so I'm going to replace that final E with an OL. This is pentanol. Pentanol. 5 carbons, single bonds, and a hydroxyl group. Right, what about a hydrocarbon that has 2 carbons, 1 double bond, and again an OH group? We've got another alcohol here. So 2 carbons, F, double bond, ene, alcohol, replace that last E with an OL, and we've got ethenol. Ethenol. So another systematic name. All right, last example, a hydrocarbon with 8 carbons. It's got a triple bond and a COOH at the end of it. So 8 carbons is oct, triple bond, ine, and COOH is a carboxylic acid, so we're going to replace that last E with an oic acid. This is octinoic acid, octinoic acid. So systematic naming takes a little practice, but once you get used to it, you can name an awful lot of things with just a few little rules like this. This is a good one for you to look for just out in the wild on product labels. So definitely look for these and try to think about how the names and the structures are related to each other, and get lots of practice. See you next time.